are broadcast as radio impulses into space. And all that they're being heard on a rear field telescope on the entire Earth.
Gave you too much, now I'm swallowed. Now I'm the fool while you're breaking rules. Dangerous path that I follow. Oh, go on, just do what you do. And it bleed for you, cry for you, oh, oh. Let me bleed. As I bleed for you, cry for you, oh, oh. Let me bleed. Let me bleed. All of the pain seems to follow, like a shadow dark and cold to the touch. Am I insane not to let go? Oh, go on, just do what you do. And it as I bleed for you, cry for you, oh, oh. Let me bleed. As I bleed for you, cry for you, oh, oh. Let me bleed.
with the playlists that I've already done. Pretty much any stream will be running through in order to reach yours, as well as your own custom RMTP site, box, and so on. And then you have little key is for Hitbox, Twitch, Hitbox, and so on. I did here, and that was my mistake. If we go to the social alerts tab, you can connect your multi-monitor, Twitch or Hitbox or YouTube gaming profile, and we're just going to point it to
The Restream Doubling feature allows users to add multiple of the same, free, supported platform, meaning you could easily stream to 2 Twitch channels, 3 YouTube channels, or as many other channels as you want. Note that doubling does not work with custom RTMP. Many users use doubling to stream to their personal channels and their team channels at the same time. After we've purchased 2 doubling options for the additional 2 YouTube channels, we'll go ahead and add the second Restream YouTube channel automatically via our API. Next, we'll be adding the 3rd YouTube channel. This one I'm going to be setting up manually, however that's not mandatory. To
Sweet. Hey guys. Okay, so yesterday we worked on some demos. So we'll continue doing that. Instead of me working on my slide deck, I think I'll do exercises and demos. A little more interesting. So where did we end off? We kind of ended off here. I think we were looking at math functions. Let's go ahead and probably do just trying to think of what I want to do. I guess we could do something along the lines with conditionals and looping, since that's where we kind of are in the slide deck. So okay, I'll dupe this slide. Let's call it, let's actually move it up because I want to get out of the function stuff we did. Cool. Alright, so I'll call this, let's do a, what do I want to do? Let's do a linear search example. Okay. And maybe I'll call it problem. Okay, hold on. So let's delete this slide. I've already got a bunch of slides where I have problems. I won't. I'm gonna copy this slide. Hey, Tom Crows, how's it going, dude? I'm gonna we're gonna work through some demos today. What I'm doing now is we'll do some problems. So the demos are kind of like what I'm gonna just show in the course as demos, and then the problems are what I will leave the viewer to work on. So let's say given let's see, given the following, maybe I might reword this, but let's say create a vector that contains, so we'll create a container, a vector of integers that contains if I tab that doesn't help me at all. So if I do that, and if I tab him, that's not very good. So much for the. Well, whatever, who cares? I mean, it doesn't really matter. Oh, it does. Jeez. Okay. Let's see. So given the following, let's just throw out some random integer values here. That's good enough. It's getting a bit hairy. So create a vector that contains the following. And like I said, I might reword that, but that's fine. And then display the index of, and this will make more sense when the course teaches vectors, but let's just say display the index of it doesn't matter, of 64. So anyway, so that's a good start. So let's open up Visual Studio and let's give this a shot. Okay. Okay. So we'll call this problem 01. So we're going to need to include our trusty IO stream. And I think we should be okay with that. Create our usual suspects here as well, return 0, and now let's give this a go. So what did the question ask? So we have to create a vector that contains those numbers. So and since this is part of the standard namespace, we have to scope through. Actually, just one sec. I just have to pause the stream for a second. This is something I forgot here. I'll be back in just a minute. All right, sorry about that. Yeah. Okay, so what am I trying to accomplish here? So we need a vector that stores integers. We could do a pushback, and we could push each individual number, but here's a better way to do it. So we'll do an initialization list, and we'll put our we will put these guys in there. So let's see what Otto comes up with. It comes up with an initializer list. So what I'm gonna do is, instead of letting Otto handle, so we can do that. And so it's a simple linear search. So basically, given an array, we're gonna loop through and find the index of that. So big O. So let's just look at the big O notation. There we go. There's my cheat sheet. So we can look at if it's on here. So we've got sorts. I was hoping to find big O of n for this, because we're gonna have to. The worst case scenario is O of n, because we're gonna have to loop through each and every element, n being the amount of elements. I don't know if I'll use the big O notation in the course. I might do it. Yeah, I probably will. I'll probably cover it. Selection sort is a real pig. The amount of elements to the second power. Maybe I'll do a selection sort as well. That's where you'll move. It's kind of like you do 2 for loops to actually sort. One to get the first element, and then to actually sort that element back in the pile. So worst case situation, you could have big O to the power of 2n. Or n to the power of 2. Pardon me. Okay, anyway, I don't know why I'm looking at that. Yeah. Okay, so let's just simply, we want to find given a container of ints, find, what did I say, 64? Find the index of 64. So we can just simply use a for loop. We can do auto I is equal to 0u. So that will define, I'm just gonna look at the, that will define, as an unsigned int, pardon me. I'm just thinking, when I was working yesterday, we covered our loops, but I didn't do the new ranged loop, which is modern C++. So maybe we should do that. Maybe we should do that. So auto I should be perfect. So now we can just, if the problem is we're gonna have to also increment. I'm gonna change that to n for number. I'm gonna go auto I 0u, and on every iteration of the loop, we will increment I, And let's just check. So n is equal to I just want to create a variable to hold. Otto. Number to find a 64. So, perfect. So, if n is equal to so this is pretty trivial, but it at least covers our range for loop and a conditional, which is what those slides were covering. So I can just go ahead and I can just do, my head's not working today. I might actually change. Let me do this, and then I'm gonna change this problem a little bit. Go back to my chat. Hey Gun, how's it going, dude? Didn't have the chat open. Hopefully you weren't hanging there. Okay, so see out the index of so I could do something like that. And we could break out of our loop because we don't want to iterate anymore and take up resources. And then we can just exit. So if we run this, just to see where we're at. And I will go into what is this called? Problem. Debug. The index of 64 is 6. So we go 0, 1, 2, 3, 4, 5. So we have a bit of a problem. I clearly incremented that too soon, because I was incrementing it before we actually needed that I. So that's the only problem. But I'm wondering, I might change this. So I'm going to actually initialize this to that. And let's prompt the user. What am I doing? So from the numbers, let's just say enter a number to find. This doesn't sound good. Given these numbers, enter number 2. Enter the number you want to find the index of. I might reword that. Okay, so now let's prompt for them to. Oh, today is horrible for me. Okay. So we'll capture the number defined. Try it again. So 1 is -7, looks good. I could even do this. I could actually, we can just loop this. Given blah, enter the number you want to find the index of. So Q to quit. Hey, Crypto Poker Show. Thanks for the follow. Appreciate it. Hope you guys have some big plans for the weekend. I don't. It's snowing in my neck of the woods, so I'll be shoveling all weekend, I think. Yay. Okay. Okay. And I probably will, yeah. This is all live and ad hoc, so I'll probably change the these examples for the course. They smell a bit. They smell. Okay, so in Q to quit. So how can we deal with? Actually, we can't say Q to quit since we capture. What should I say? Well, you know what? I'm not going to do it anyway. I mean, I can, but I just don't want to throw in a while loop and look for a certain input in loop and have them keep adding this. For a problem, I think that's a bit tricky for someone who's getting into C++. So find the index of number to find. Okay. I might change this. I'm not overly happy with this, but it'll do for now. So I'll close this. And we'll create another problem. So problem 2. So what are some of the stuff I've jotted down here? Oh, I know what I need to do. So let's go back to, I created another problem. Where the heck did I put it? I have a relational problem. Hey, Bubble Dad 12, how's it going? Oh, here we go. Cool. I want to move that up here. So let's do this one. So I need to do this as well. So given bool A is true, bool B is false, bool C is true, bool D is false, what do the following evaluate to? So let's go ahead and do that in Visual Studio. So problem 2. IO stream. Int main turn 0. So okay, so what does the question ask? So we know we have to set up some bools. So I'll copy that. I'm gonna get grief that the casing on the variable identifier is a bit ridiculous, but that's okay. So now I'm gonna copy each one of these problems if I can. If I copy that, I don't know if it'll paste as text. Good enough. I assume this is one. And obviously I'm going to turf this out of here shortly, but it gets me going. Okay, good. So we've got, we just need to see out these things. So std see out. So I need to, there's a command called std alpha. Okay, I'm gonna have to cheat. This is more like a demo-y C++ thing. In C++, or here I'll show you. Show you what we can fix it shortly. But you'll see the problem in a second. So let's go ahead and B or D. We're just going to simply do all of these problems to the console. And we can work through them as well. So we know our logical OR. So we've got B, which is false. And remember our logical OR truth table. As long as one side in this binary operation or binary expression evaluates to true, then the statement evaluates to true. So as long as one of these is true and one of them is, this will evaluate to true. So we know that that's going to evaluate to true. And we'll work through the next one. So it looks like question 2 is this. Copy that. Cool. So let's look at this. So the problem with the logical AND is the left hand or right hand side, so every operand needs to be true for this to evaluate to true. Okay? And that won't be the case. We know that there's at least one false out of this, I think. The D. Okay. So let's copy again. Now we got to start actually creating some more complex logic. So we learned about relational operators. Okay? Our logical OR, our logical AND, and our logical NOT. Right? But these A and B's, we can replace them into more complex statements, right? And we looked at this, so we can actually push this all together, and we'll do that. Sorry, I'm kind of all over the place this morning. Need to calm down. I guess I haven't had enough coffee, so, or I've had too much. Okay, so I will copy that in there. So what do we get here? So we flip the outcome of A. So if it's true, it's going to become false. B is false. D is also false. And we flip C, which is true. So this statement will evaluate to false. So I believe that was 3. So we did 3, we did 2, and we did 1. So let's do 4. Okay. So we've got that one. So what do we have here? So remember the parentheses set precedence. So this logical not won't occur until this group inside this parenthesis set evaluates. So A or B, we know this is going to evaluate to true. We flip it and it becomes false. Okay. So that was 4. So I'm just going to cut this out. And we will do okay, so A, which is true, not B, which will become true, true, and true. So that'll evaluate to true. So let's have a look at this guy. So we always go into the innermost parentheses. So this group of parentheses, we find that there's more parentheses inside, and there's 2 that are peers. They're at the same level. So it doesn't matter which one we evaluate first. A, true, B, false evaluates to false, but we flip that to become true. And then we're trying to AND the right-hand side. So the right-hand side is false and false, but we flip that and it becomes true. So this whole expression should result in true. Okay, that was 6. So let's now do, let's do this guy. Okay. Okay, now if we look at this, so we can do the parenthesis check. So we drill down. And this guy is clearly the innermost parentheses, so he takes precedence over everything. So we flip C, so it becomes false. That's false. And then we evaluate the group in this parenthesis set. So it's basically whatever B is, which is false, and the outcome of this parenthesis set, which we evaluated to false. So this group right here is false. And we OR a false to a false. So this statement all becomes false. So false and D true, this becomes false. But this outermost logical not will flip that to a true. Okay. So let's turf this. And let's run this. Let's put the breakpoint here. So we've got a true, a false, a false, a false, a true, and a true. So I'm going to add one quick line of code to our cout output stream to tell future couts to take any Boolean value and express them as a literal Boolean value, not a numeric Boolean value. So this will become true, false, 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 true, 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 or sorry, false, false, false. So I need to cout. It's called alpha something, bool alpha. So I just need to push std bool alpha into the cout stream, before I emit out those Boolean values, and they'll show as bool. So I just needed to refresh what that statement was. It's not really common. It's more for demo purposes because it's, you know, STD. Bool alpha. Perfect. So now if I run this, we can see the outcome as true, false, 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 true, true, true. Cool. That will do. So I actually am going to do this. I am going to so it reads a little better for people. Okay, almost there. And this way it should be more readable. So, right. That'll do. I am not going to put... This is just like anyone who's working on the problems, if they choose to, they can see on GitHub the solution to them. So let's see what else I've got. I did a stream online G. So there is an online compiler. If you guys want to do C++, you can go to onlinegdb.com. You can follow along with what we're doing here, because it has a full online compiler. It's a little touch and go. It works well, but just choose C++ 14 and it works okay. Just sometimes I've noticed it really slows down. I don't know if their servers are slow or if it's being used. I'm just gonna log in, because I did a bunch of these demos already. And I don't really want to type them all in again. And I want to remember, because I kind of did this course on the stream a couple weeks ago. But it was more just kind of offhand teaching. And I think I'll move a lot of these examples into Visual Studio and push them to GitHub. Okay, so this is definitely not interesting. Let's look at this problem. So the average. So what do we got here? Yeah. These are problems for the first course, I think. Or for the first section we already did. Okay, cool. I already did that. So I already had that. Brilliant. So I think that was problem 5. Problem 6. Okay, this is good. So we'll use this where... Okay. So let's do this as a problem. So given 5.5f as a float, a boolean, an integer, and a char, we can evaluate these expressions. Perfect. So if we go back to our slides, so I've got the problem done for our relational operations. Now we can use our relational operators. So this will show us our relational operators, our equal, not equal, greater than, to evaluate into a boolean. And then we'll use this in conjunction with an if statement. So we can do a conditional against this stuff. So I'm just going to copy this. We'll call it problem 3. Okay, so let's have a look at this. So IO stream using STD. I've been not doing that as much, so I'm gonna remove this. Keep everything kind of copacetic here. Okay, so now let's look at this. I can just auto these guys. Okay, so A greater than or equal to C. So 5.5, is it greater than or equal to 9? Well, no. I'm going to also add that bool alpha. Perfect. Redundant literal. Yeah, I get it. Accent identical. Yeah, I get it. That's the idea. So we can do this. So I'll put this out in a problem, but we can work through this. So is A greater than or equal to C? Well, no. 5.5 as a float is not greater than or equal to 9 as a whole integer number. D is equal to itself. That will evaluate to true. C not equal to D. So we have 9. Is it not equal to 9 char? We know it's a char by hovering over it. Well, no. I mean, they maybe represent somewhat the similar thing, but this is an ASCII 9 value. This is a char, right? So that's not going to be the same. So B, which is true, is that not equal to false? Well, that'll evaluate to true, right? True is not equal to false, and that'll evaluate to true. So C, which is 9 int, is it less than or equal to D? Well, I believe so. We can look at the ASCII table, and we can find out. So we know 9 is right here, and it evaluates to 57. Earlier slides, we talked about char and how it's actually an integer value. It isn't a string value. It's an integer value that represents an ASCII value. So that was on a previous slide. We covered that. Okay, so C less than or equal to D. That should be true because 9 is less than 50 whatever it was on the ASCII table. Okay, so B is equal to, what will that evaluate to? It'll just evaluate to true. And D is equal to C, again, false, because the integer representation and the ASCII representation, the char representation, is not the same. So we can run this. And that quickly disappeared, but I am going to run it here. Problem 3. Tab, tab, tab. I guess I have to cd out. So if we run problem 3, there we go. Those outputs should be correct. Okay, so now I need to make a slide for that. I'll have to change that problem because we're letting the user decide. So let's try this. Actually, I should probably just copy this because it's... Okay, so now let me shift that guy over. I need to see this stuff. So given float, I get that that might be a little bit tight to see me type. I don't know if you really care because it's the same. I'm just typing out what was in the code. So 5.5 F, B is true, it's a bool. C is an int. 9 and char for D, and it is equal to 9 as a char. Given that, what would the following evaluate to? Brilliant. Okay, so we can go A greater than or equal to C, D equal to D, B not equal to false, C less than or equal to D, B all on its lonesome. You can only do that with something that is of a Boolean type, obviously, because these expressions have to evaluate to a Boolean. Perfect. So I'll cut that. Okay, so that's problem 2 done. Let's make this big. Okay, so that was problem 6. Let's get 7. 7 is almost the same. Clearly I went a bit crazy. Actually, that's good. This is good. Let me open up. Hey, BubbleDad12, thanks for the follow. I must have missed that. Sorry about that. Okay, I just want to open in a new tab, problem 7 and problem 6, just so we can see. Snap. Oh, it's wanting to go on my other monitor. Okay, so this is the problem we just finished. We just have our relational operators evaluating in a binary fashion where we just have a left and a right hand side. So this takes the exact same values, but we make it a compound binary where we have binary operation in a larger expression, right? So what is this expression going to evaluate to? Well, that's great. We're now using our logical operators and our relational operators together to evaluate to a true or false. So this is becoming closer to what you would use in, let's say, an if statement, right? You know, this is also what you would see in an if statement, but sometimes you get more complex expressions in an if statement where, you know, A has to be greater than or equal to C, but also if D is equal to D, then we'll let it slide. We'll evaluate to true and go inside of that if statement. In this case, right? Because it's a logical or. So if this is true or this is true, then go ahead and go in the if. Anyway, that should be kind of straightforward. We covered that stuff yesterday. Yeah, so I'm just going to copy all this. Okay, let's go to Visual Studio. I just want to make sure this looks okay, because I'm going to push that to GitHub in a bit. Okay, good. Close solution. Get big. So where are we at? Problem 4, right? Problem 04. I don't know how long I'll go today. It just depends. Like, I need to actually get on the slide work. I've got all these demos and problems that I'm working on, and I keep avoiding doing my slides. I may do slides in a bit. It's not fun though. Okay, so I'll auto these, even though in the slides we represent them as the data type, not as the auto, which is the compiler will imply what the data type is based on what you're assigning to it. So let's add our std bool alpha. Oh, I better. It only performs against that operator of insertion. Cout. So here, std. Clearly, I am. Okay. So let's look at this. Is A greater than or equal to C? Nope, that evaluates to false. Is D equal to D? That's true. And since this is a binary expression, A with this relational operator and the C on the... So we've got a left-hand operand, a right-hand operand. Hence is binary. There's two. So this is a binary expression. This is a binary expression as well. These guys will eventually evaluate to a true or a false. And then again, we have a real granddaddy outer binary expression, right? Which is the result of this binary expression and this binary expression. The result of them create a final binary expression. So we know the left hand, this will evaluate to false. This will evaluate to true. And because it's a logical OR, as long as one of the operands is true, the whole expression becomes true. So we know that'll be true. B B logical and B, so true and true. Remember the truth table for a logical and, as long as both sides are true, then it evaluates to true. Otherwise it's always false. So that's true. So we know this expression right here is true. I need to cover short circuiting. So short circuiting is in C++, in C#, in Java, basically in JavaScript, almost any language, there's short circuiting in your in your statements, in your expressions. And what I mean by that is if we have a logical OR and it evaluates left to right, if this logical OR evaluates this left-hand side as true, it won't even look at the right-hand side. It short circuits because a logical OR, as soon as it encounters the first true, that whole expression becomes true. So there's no point evaluating any further. And with a logical AND, the same holds true. If in a logical AND, we remember the truth table for a logical AND, the only way a logical AND evaluates to true is if both sides are true. Therefore, if this is false, this will always become false no matter what the right-hand side evaluates to. So the short circuiting occurs also in a logical AND if the left-hand side is a false, because there's no point evaluating anymore, right? There's no point. So that if this became false, this whole expression would short circuit, and there's no point to take up CPU ticks or clock ticks or CPU cycles evaluating things that are irrelevant, right? Anything after that. So short circuiting occurs with a logical OR when it evaluates a true in any place, and a logical AND short circuits whenever it sees a false in any one of its operands. Okay, hopefully that makes sense. Okay, so we've got this third one here. Is A less than D? Yeah, it is, because we looked at the ASCII table and we know that 9 on the ASCII table is 53 or something like that. So we know that 5.5, even though it's a different data type, it's a float, it doesn't matter. We still can do these relational operators against different types. That's fine. Numeric types. Numeric being floating point and integer are a numeric type. Okay. And also, this char is a numeric type as well. But it has a weird behavior that we covered before. Okay, sorry. So this evaluates to true. Now we jump into our parentheses and evaluate this whole statement. So we can read left to right because there's no more parentheses to deal with. So we flip B because we add the logical not. So B from true becomes a false. So as soon as we see a false, we would normally short circuit on a logical AND, but we have a logical OR, so we're checking for a true. C is equal to itself. Well, that will definitely be a true. So this evaluates to true, and this evaluates to true. So the logical AND has a true on the left and a true on the right. Therefore, this will be a true statement. Okay, so now we have some literal values mixed in with our variables. Literals, when you hear the term literal, it means it's a literal value. This is a literal 9 int. This is a literal 9 char. This is a literal 9 int. This is a literal 5.5 F for float. I'll fix that. If I don't put the F, if I don't put the type suffix, that will be a double. Okay, so we wanna explicitly define that as float. Remember suffixes for type suffixes. It's irrelevant suffixes. Is that right? I think so. Capital is just as the same as lowercase. That's one of the few cases where casing is irrelevant in C++. So I can put a capital F or a lowercase f. It doesn't matter. And I'll actually lowercase this. Okay, so let's look through this. So the D is a literal char 9. So that is not equal to a literal integer 9. Or literal char 9 is less than or equal to integer 9 literal. Well, that's false, just because we know that the literal char 9 is 53. Do I still have that ASCII table? So I keep 57. 57. So 57 is what this would evaluate to as an integer, and it definitely isn't less than or equal to 9 as an integer. So A, 5.5f, not equal to 5.5f. Well, that's false because they're equal. So we got a false, we've got a false, and we've got a false. So this evaluates to false. But the sneaky logical not wraps this whole parenthesis, this whole group. So it flips that false to a true. Okay, so then this one gets a little greasier. We got to find our innermost parentheses. We can start here. A is less than C. That's true. D is not equal to A. That is true. But we flip that to become a false. Therefore, this whole expression here will become false. Let's just follow our parentheses. So that's false. And so it's irrelevant what this is because we got a false. So this whole expression in here becomes a false. I just hope I'm following the parentheses right. But then we flip it to become a true. Then we flip that again to become a false. So yeah, it's a little hairy, but we get the gist. Okay, I'm gonna just kind of make this a little more readable here. And then we'll run this. Okay. So Control-Shift-V, and I'll just run it. Oh, 4. So there we go. Those are the results of those expressions. Simple as that. More or less. So I'm going to copy, create our slide. I will copy this slide. I'll dupe it. So not much changes here. Our A is still 5.5. Our B is still a float or a bool true. Yeah, so all that's the same. It's just me changing these now. So I can just copy. That'll cover that slide. Guy's a bit hairy. Okay, sounds good. So we'll close this solution. So let's look at what we've got. Probably, I'll look at the ternary and switch and if. We didn't cover the ternary in our conditional. I'll do this as see what demos we got. So we got our loops. I got to do a range loop demo. Suppose I should do that now. So what can we do? So we can, let's go ahead. I need an initialization list. It's just, I haven't covered vectors yet. I could use an initialization list and loop through. So we'll just call this list. And we can just define auto I. I'll define it as n because I is typically used with an indexer. So this is the actual number itself. std out. So I'll copy this. Create a new project for that. We'll just call it ranged. I can just call it ranged. Good enough. Oh, I did a factorial recursive. Yeah, maybe I'll do that as a problem. Okay, so let's add our CPP file, and I'll just paste this. I don't think I'll need that. Oh, I do for the toString. Okay, so what is our list? We have an initializer list here containing ints. Something I guess gets covered more with our vector stuff, but this is good. So let's just make sure this runs and looks okay. And then we'll move on to factorial recursive calls. So yeah, perfect, 1 through 10. Yo, Vinny. Hey, if I want to get into programming, what language do you think I should start with? I don't know. I mean, it's kind of a tough one. Like, there's kind of a stigma around C and C++ being difficult. And that kind of was the case before like 2011, when this concept of modern C++ came out, where it abstracted away some of the nasty, kind of didn't remove pointers, but added some smart pointers where it would actually know the reference count and call your destructor as necessary. You know, but to start, it depends. I mean, it depends. If you've got zero background, you know, you could just start with maybe what area you want to look at. Like if your interest is, if you want to become, let's say, a game programmer, then maybe you should start with C, C++. That's not necessary nowadays. I mean, you can program games in almost any language, but, you know, if you ever get into like real world game programming, actually work for companies, you probably will need C++ no matter what. You've done scripting in PowerShell. Okay, so you're a Windows guy. Why don't you use C#? There's tons of tutorials on C#, so it's such a mainstream language that if you ever bump into problems, you can Google it and you would find a solution. I would choose a language that is so mainstream that when you run into problems, you could simply Google, and you'd be guaranteed to find 20 answers. And what languages would those be? Python now would be up there. C# would be in that realm. Java definitely. JavaScript definitely. C++ definitely. So those would be kind of the kings. We talked about this yesterday briefly. Tyobe index. We looked at this Tyobe index to look at the most popular languages. It's not that any are really much harder than the other or easier than the other. It's just you probably want to learn a language that has some traction as well. Like VB, I guess, is climbing up. It's at 6 in the ranking this year versus 8 last year. Let me make this a little bigger. But I wouldn't recommend VB.net. I don't know. I mean, most .NET developers use C#. Most companies use C#. JavaScript looks like it's dropping a notch. I'm a bit surprised on that, but so be it. I wouldn't learn Ruby. No, I shouldn't say that. I wouldn't learn that. I wouldn't learn Delphi or Pascal. Old stuff. It's there. It's only up in the list because there's lots of legacy code. Hey, Vinny, thanks for the follow. SQL, that's not... It's a programming language in sorts, but it's really a query language for relational databases. So you would need to know SQL, though, if you want to become a web developer, any sort of back-end or enterprise development, you're going to need SQL. But let's see. Don't learn anything below the top 5. How's that sound? Any of these top 5 would be like the best languages to know. If you know any of these, you'll know the other one, or you'll be able to learn the other one. Python is a little bit different syntactically than the other languages, but you could literally take a very simple C program and drop it into a Java compiler and it would run. It would run in C++, and it would run in C# with some minimal changes. Like, for example, C#, this would almost run, except this include concept, but you would change the main to like main, like capital M. Java, this would run literally as you see it, short of like, obviously these includes. And this range for loop is a little bit different than the syntax, but it's so close. Yeah, I guess I kind of went off on that. Learn any one of these top 5 and you can't go wrong. How's that sound? Okay, so what am I doing here? So we got the initializer lists, and we printed it out. So let's close this. And then we want to do a recursive. So you do SQL as well. PowerShell. If you're a network admin, why don't you learn Python? Python's a powerful scripting language, and that's kind of the way things are moving. You'll find lots of Python books on scripting network administrative work. So Python is probably maybe your best bet. Okay, so I need to create a new solution, new project, but before I do that, I want to find my recursive. I've got a... Where the heck did I put it? Maybe it's problem 8 through 9 or whatever. Maybe I can use this. Enter a positive int to calculate. Okay, perfect. Factorial. So we can do this. But before I do this, we'll explain it in a sec. I just want to look at the other problems I did a couple of weeks ago. That's lovely. Okay, good. So what is this? Enter as many positive ints as you want. Enter any negative number to end. And we'll push that. Yeah, that's a good one. We'll go through that in a sec. That's pretty much what we already did. Jada store. Oh, so this is a selection sort. So we could do that as well. I probably should. Okay, good. So we got some stuff to do here. Let's look at function 01. I just want to see what this is. Calculate area, add number. Okay, we'll probably do all of these as demos and projects. So let's go to problem 8. Got my big bottle of club soda through my throat. Alright. Okay, so what are we doing here? Enter, oh, so we're gonna do factorial. So how does factorial work? So this works like, so n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 and minus I just need to go n minus n plus 1. That's kind of the proof, I guess, mathematically. So I'll explain what's going on here. You know, I'm going to copy this first. We'll put it in Visual Studio. I'm just thinking, should this be a demo? No, we'll call it problem. What problem were we on? Problem 5 or 4? Problem 4. Let me just CD up. I think we did problem 5 as well. So we got problem 4. Okay, good. So we'll go problem 5. I should probably do a slide here too. I have to renumber these. So, okay, so we accept input from the user. Prompt the user for a positive integer and calculate the factorial of that integer. And then I probably should just control I to get italics and just say, you know, n factorial is equal to I might do that. Because eventually this will evaluate to n minus you just calculate until n becomes 0. So you're just negating 1 off of n and multiplying it by the resultant, right? And then multiplying it by the next decrement. It's kind of, you're just constantly decrementing that. So I'll copy this, and then we'll have our slide, and then we'll go into code here. Something like that. I might update that in a bit. But... Okay, so did I copy? I didn't copy it, but I lost it. Okay. So let's add our CPP. Stream, let's turf the using. Let's get rid of this comment. We can just go Otto. Good enough. Enter a positive int to calculate n factorial. Capture the user's input and the results. We can just say 0. But let's actually 1 u. The reason why we have 1 is because we're just going to use the compound arithmetic operator, multiply equal to, right? That just is the same as saying result multiplied by I. So we can just shortcut that with this compound. Okay, so now let's loop through. So I starts at 1. Well, I is less than or equal to the number the user entered. We're just going to loop. So we could actually invert this. Maybe this is better. Input. And well, I is greater than I is greater than 0. Well, I is greater than 0, then we multiply. So that's fine. So our I is going to be our number. This will be our indexer as we loop through. Okay, so we've declared and defined I to hold the value of whatever the user entered. And then we decrement. So we're doing, if we go back to the slide, this here, we're basically doing this. We're taking n and we're multiplying it by n minus 1. Yeah, and we'll see that in the code. So I, when we first multiply into result, it'll be the value of whatever the input was, and then we decrement right after that first iteration occurs. So I now is whatever you entered minus 1, and we multiply it. Yeah, perfect. And then we break out when I becomes 0, because we don't want to multiply by 0. Otherwise, it negates the whole result. So blah factorial is equal to result. Okay, I think that should work. I'll drop a breakpoint. I can just control F5. Let's see what we got. Okay, so if we say factorial 10. Did I have what happened? There we go. So we've got 3.6. So we can stop that. So does that seem right though? That doesn't seem right. Doesn't seem right at all. Let me just do a sanity check. It's 10 multiplied by 9. Well, maybe multiplied by 8. By 7. Yeah, I guess so. Oh. Do I even have factorial on here? Or I could just do 10 bang. Oh, it is. Cool. Brilliant. Okay. Yeah, it's all good. It's all good. So the logic is good. So hopefully that makes sense to you. Yeah, this will create our n minus 1, because we're just taking n to begin with in the first iteration of the loop, and we're minusing 1 off it on every iteration of the loop. So it'll just keep going and going and going until 1, right? And we know it's going to be the final multiplication will be against a value of 1, because as long as I, we're counting it down to 0, but as long as I is greater than 0, we'll do an iteration of the loop. So once I hit 0, we exit the loop. The previous iteration I would have been 1, right? Because we're decrementing it by 1. So yeah, we get that. Okay. I think we're good. Does Otto have any performance cost as opposed? No, because it happens at compile time. And one way to verify that is, you know, it happens at compile time, not at runtime. Because if I declare Otto without assigning something to it, it can't infer the type. As soon as I say 5.5, it'll be a double. So I hover over, it becomes a double. So just by the very fact that you can hover over a variable and see its type, tells you at compile time the IDE, the compiler, knows about the type before you even compile into machine code. So this is just syntactic sugar. Otto is it's just total syntactic sugar added in C++ 11. Yeah, the performance difference is irrelevant because there is no. When it compiles, it'll change that type to a double. Hopefully that makes sense. So what's the benefit you gain by user Otto? Explicitly declaring the type seems like it would be easier to... Yeah, exactly. I used to... I think somebody asked me the same question like a week ago when I was streaming. And sorry, I just was looking at my chat. Okay. Yeah, somebody asked me the same question about the readability, and I get it. I think my response was, I ran a project for like a state level government, and it was to build this. We built the framework that all future development would be based on. So it was just like a library or framework. And I had a guy who used the var keyword. It was in C#, and he used the var keyword all the time, and it drove me insane because I like to be able to just look at the code from a distance and know what the type is. I just do. And I kind of was against the var keyword. Like I wouldn't let him do it. So some companies, you know, let's put it this way. The var keyword in C# is the same as the Otto keyword in C++. Because this is a course on modern C++, I'm trying to use the constructs and the syntactic sugar that you get with modern C++. I honestly am not a big fan of Otto myself. Yeah, it seems exactly. That's what the other guy said. It seems lazy. But there are cases where you can use a lambda function that has a complex outcome that would be variant, and you don't know the outcome of that lambda function until runtime. So you need to use the Otto keyword in some cases. I don't have an example off the top of my head, but there's some really complex expressions in a lambda that you would need to use the auto queue, because you just don't know what the type is until actually execution and runtime, because it could be variant based on different outcomes inside the Lambda. So the auto is necessary now that there's the concept of Lambdas, but it isn't necessary in this example where I'm defining a variable. Like I could just as well put in double, right? Or in this case, enter a positive, so it'd be unsigned. Int is really the true value of what this should be. All right, unsigned int. So yeah, I'm with you. I won't argue if somebody says it seems lazy. I won't argue. I totally won't. And it depends on the convention of your company. Let's look at Google's convention. C++ naming. Let's just look at their, yeah, I was there before. Let's just do a Control F for Otto. See what they have to say. Use Otto to avoid type names that are noisy, obvious, or unimportant. That's a good point. So if we go back to this, this isn't, we need to not, like here's where I would, you would use Otto, and that should be perfectly valid, where it's just an indexer for your for loop. That makes perfect sense as an auto, but I know like int is just as quick, but even that isn't valid because it should be an unsigned int. But yeah, like that's what Google is trying to say, is where it's unimportant or it could be noisy. Let's go back to this. Can you continue to use manifest type declarations when it helps readability? So explicitly declare the type. Sometimes code is clear when types are manifest, especially when a variable's initialization depends on things that were declared far away. So this is saying this is not cool, right? Because it's a lot easier to be able to infer the type as a developer looking at code when you saw to the right hand side that this said 5.5f, right? But Google is saying this is very convoluted. You probably won't know what add foo returns. It could return a bool like you did an add and you get the result saying it was successful, so it could be Boolean. You don't know if if this is going to return a string. It's very difficult to tell. So Google is just saying, unless it's obvious, use Otto for obvious types. Unimportant again would be like this, that indexer in the, as you increment your for loop. Yeah, so that's kind of when you would use Otto. If you look at more current demo code on the internet, people use Otto a lot. The people who create the demo code use Otto a lot. So I'm following that convention, but I don't condone it. Google has one of the worst naming conventions I've ever seen. Yeah, well, yeah. I use the dude's what's that company? Airbnb. So Airbnb, so I've been doing a lot of full stack JavaScript, and this is one of the conventions that we follow. So everybody seems to have their own convention. It's up to you to implement what you want, throw out what you don't like. It's really up to you. So anyway. Yeah, just think of Otto, syntactic sugar. What's your opinion on static members to avoid using? Yeah, definitely, right? I mean, definitely you would use static, and we'll get into that where we define some classes and we'll define some static members inside of them, for sure. So, you know, and in my cases, I may throw global stuff up, but Yeah, mostly it's not so common. Typically, and I know people still harp on macros where you can define types. You know, you would define a, you could define, and then everywhere you want to use X, you know, it represents 1, 2, 3, 4, or whatever. I'm going off topic. Okay, so I'm cool with this calculate factorial thing. I think it'll work okay. Let's go back to our slide quickly, just to see if I entered in what I need to enter. Should be more like this. Prompt the user for a positive integer and calculate the factorial of that integer. I may change that up a bit, but so far it looks all right. Okay, so that slide's done. That demo is done. Close solution. So let's go back to here. Look at some of these projects I've already done. Hey, Gun. Yeah, don't worry about it. I don't mind. I like questions. I like to go off topic. Kind of gives my head a break of, like, I'm so kind of focused on trying to figure out these things. It's kind of nice to have a distraction. So feel free. You guys, you can flood the chat. I kind of have one of those days today, too. I wouldn't mind, I don't know. Okay, yeah, we'll do this one in a bit. So 11. Let's go back to projects. I'll leave. Oh. So I think we did 8. Yeah, maybe I'll... Let's see. So this one, we have a vector that holds integers. So it's like an array. It's a container. We'll accept the user input. So this is good because we do our loop, which is prompting the user to continuously enter in positive numbers. If a negative number is found, we exit out of the loop. If the vectors has elements in it, then we're going to use the range for loop to emit those out to the console. Else we're going to say. So I might do this as a demo. So let me copy this. So I guess we'll call it vector demo. Hey, sorry, I fell back on the chat. Let me have a look. So Tim Orts, in C++, you usually want to avoid to put things in the globe. Yeah, absolutely. Yeah, I completely 100%. Tim Orts. Gun Games, I still slowly but surely making progress. What are you working on, man? In this 2D engine I'm making using SDL2. Gonna eventually use it to make Contra and Metal Slug. That would be cool. I actually Googled, I think it's called CC64, like is in Commodore 64. It's a compiler for Atari 2600. C compiler. I remember looking at this. I shouldn't even say it. I didn't even look at it. Other than I know of its existence. But I found that maybe making games on old platforms as kind of a good exercise, a bit of a coding dojo. I used to do that when I worked. We did a lot of enterprise development at this one company, and I kind of got into the habit of, like, every so often I would just do something crazy, like, and call it like my dojo work, where it would just be like I'd do some crazy SQL stuff, and this would be kind of the same example where I would just do some dojo creating a C++ game for Atari 2600 or NES or Super NES, those old consoles. Yeah, but this CC65 compiler is something I wanted to look at because it supports old 6502 Intel chip machines, which would include VIC-20. I don't know what these are. I know Commodore 64. I didn't know there was a Commodore 128. I assume that's what that is. PET. That's Commodore PET, right? Yeah. Apple II Plus and successors. So I guess like Apple IIe and Apple IIc. Apple IIc was my very first computer. I don't even barely remember it. I can't believe my parents, like back in the day, that cost like a lot of money. Atari 8-bit machines, Atari 5200, Apple again, TurboGrafx 16, I think I vaguely remember that, NES. So I kind of wanted to like junk around with that a bit. Let's look at some of the Windows snapshots. Still doing the do, I see, and now you got a camera. Yeah, I figured out how to get the camera working on the stream. It wasn't hard, I guess I just never looked at how to do it. I need to make this chat a little bigger. I can hardly... Timort, I'm also working on a game using Chromium Embedded Framework. Is that what that says? Yeah. Chromium Embedded Framework to make web interface for a game using HTML with OpenGL. Would that be like WebGL? I looked at WebGL a while ago. I didn't get far, but... what's this, PUBG? What's PUBG? PlayerUnknown Battlegrounds. Oh, I've never played that. That thing's huge, though. It's only got 6 out of 10 on Steam. I've never even watched it in action. Actually, that's a lie. I think I've seen like a quick stream of it. Some guy was running through some sort of force field shield or something. I don't know. The client and PUBG used for this example for their interface. Adobe Air. Anyway, so let's see. So what am I trying to accomplish here? So vector demo. So let's go ahead and add a new source file. Just copy this. And then we'll go through this in the code. So I'm going to dump my using statement. I'll alt enter through. Okay, so right on. So here we've declared our vector. That's a container from the standard library that holds integer elements. So yeah, that's good. So the user is going to enter in how many numbers he's going to store in that container. So we just loop and you enter in a number and it will get pushed onto the back of the vector. As soon as you enter in a negative number, then we jump out of the loop. So we use our do while loop for this because we always want to do at least one iteration of the loop where we emit back what the user entered. As long as it is a positive number, we will push it onto the vector. And it's push back, not push front. Vectors are just like arrays. They take contiguous memory. So like your RAM in your computer is composed of memory blocks, and they're like contiguous memory blocks. In that would be a block, that would be a block, that would be a block. Each one of these little squares is a block of your memory. And so in our case, our vector contains integer elements. They are 4 bytes in size. So let's assume each one of these blocks is a 4-byte block. Now, when we declare that vector, it's going to default to a certain size. And I haven't looked that up, I should. But you can also declare it to have an initial size. But anyway, as you push integer elements onto this vector, they get pushed to the back of the vector, and then it just goes down and finds, like let's say we stored 100 in this block, and the user entered in 9, let's see, entered in 25, and then the user is going to enter in 10. This if statement, 10 is greater than or equal to 0, so we're going to push onto that vector from the back all the way until we find the first open element, and we would push that 10. And then what happens is, once all of these are consumed and we try to push more elements onto this vector, it has to resize itself. Because with a vector, all of the elements on it are within contiguous space. They have to be side by side. So if it runs out of space, it resizes itself, basically doubles itself in size is the rule of thumb. And then it allows you to push more integers onto that vector. The thing with the performance of a vector is if it has to resize itself, like you're pushing a lot of elements onto it and it grows bigger than it has already allotted slots for, the resizing takes quite a bit of overhead because it has to reserve enough memory blocks for its new size. It's got to go and reserve them, and then it's got to copy all of the values in those existing memory blocks to this new contiguous block of space. So vectors are great, but once you trigger a resize, that can definitely slow down a video game. So what we do is when we initialize a vector, we typically will initialize it to a fair size that will normally hold everything we want. And we built a video game. Yeah, I could use empty. You're right, Timor. I'm with you, bud. So we built a video game last week, and I think we pooled the bad guys in the video game. So we put them in a vector. So in video games, you'll typically create like a vector that holds instances of your game objects. And let's say an example is like you're a player and you're shooting bullets. Each one of those bullets will be, let's say, a class in C++. And you know, as soon as those bullets shoot off the screen or they impact into somebody or something, they're no longer on the game screen. So, you know, you may think of destroying those bullets and releasing that memory. But then as soon as the player shoots more bullets, you have to instantiate those bullet objects and add a bunch to the screen. And there's so much overhead when you do that. What we did last week is we created a vector that held our bad guys. I think we just called them baddies. And it held our bad guy objects, which is a class we defined. And whenever the bad guy was eaten or destroyed, instead of actually destroying him out of memory, we just set him to deactivated and pushed him back onto the pool of bad guys. And then if we ever need to render a new bad guy on the game screen, we would always have one in the vector. There would always be a queued up bunch in the vector. So yeah. Yeah, a bit of a tangential alert there, but whatever. So that's probably exactly what Tim Ort just said. We could use empty. And that's exactly it. Like, that's my actual resharper tool actually gave that exact same tip that Tim Ort also pointed out. So if it isn't empty, we can do this. Else there's nothing to see here. Binvarm, oh, I can't pronounce that. Vinny is following. So we got Crypto Poker Show, Bubble Dad 12, Vinny Omerta, and Burvar. I can't pronounce it. I'm sorry, dude. I tried. I don't want to make a fool of myself and bastardize the pronunciation of your name. Okay, so this is good enough. We can just run this. And zero's accepted, anything negative isn't. So that looked okay. So I'll run it now inside of vector demo.
Now add tens of thousands of your closest friends. You're losing your mind as the world's toughest and fastest skaters race down a massive track of ice at 80 kilometers an hour. It's the biggest, baddest
so let's just, I just want to run this through.
And it's back. Red Bull Crashed Ice Edmonton, March 9th and 10th. Get your tickets.
The elements you entered are, yeah, looks good. So I am going to, I need to make a slide here, guys. So let's take a few moments. So conditionals. So that demo contained loops, conditionals, and our vector. I'm going to actually do this. And I'm going to copy that code. I think I'll shrink it to fit. Let's see how bad that looks though. If I present this. Yeah, that'll do. So demo. Turf that, and I will just, oh, I closed my command. That's okay. So let's CD into C training, CD repo, section, oh, CPP training. Okay. All right, CDs. I thought I had that right. Good. Okay. So I'll just run this. I just need to get a snapshot of this. And it's called vector demo. Enter. And my snip tool. I don't like that. I'm gonna try it again. I'm not too accurate with this. I don't really care that much. As long as I may be a bit on the large side. Probably didn't need the extra and L statement there, but whatever. We'll see how this looks. I can shrink it down a tad too, so that's not bad. That'll do. That'll do for now. I just learned about removing the class constructor by using delete. I can't figure out what the purpose of this is. Why would you look at instantiation of class? Yeah, we're going to talk about copy constructors as well. I've read more, figured, okay, I'm creating a course and following. Okay, this is at me. I'm creating one. What am I building? I'm just doing demos there, Mema. So I'm creating this course. I started it on Twitch about a couple of weeks ago. So you can look at the previous, and so where we started was here. So we did this last week. We actually worked through slides I already prepared. So we got through, I'll quickly just hover over the slides. So we got through some very basic stuff. I need to remember where we left off. So we covered all the data types, variables, arithmetic operations, compound operators, precedence. So we covered section 1. And so now I am doing relational operators, logical operators, and then how that works with conditional statements. And then we cover loops, and then vectors and functions in this section. So there's quite a bit. So what I've been doing as of yesterday is just doing the demos for this section. So we did this demo, all of these demos, and then today I started adding some problems. So vectors, relationals, conditionals, looping. And then I told everybody all of the stuff that we've done, I'm just pushing up to GitHub. So you can pull or look at any of what we've done up here. So on that note, I am going to push what we've got so far. So there's a bit of stuff to go up there. So git add, git status. So we're going to push up problem 1, 2, 3, 4, 5, ranged loop demo, and vector demo. Okay. Yeah, I'm trying to do C++ 17 as well. A majority, though, is C++ 11. The music seems to be a bit loud compared to... Hold on. How's that music sound? Should be coming through now. The change. I dropped the input level bar or whatever a little bit. I think that should do it. So now let's commit this stuff. Okay, so that's pushed. So now let's look at some of the, it's low now. Too low? Too low. Maybe it's where my, I hate this mic though. It's kind of like, I can up the volume on the sound a bit. Kind of upped it a tad, but it's fine. Okay, well, I'll drop it a tad there too. Okay, let's see. Okay, so what do I got going on here? So what problems are we at? That's what we just did. And these were just out of the blue demos I did on Twitch 2 weeks ago. I was just kind of, I just got into streaming and I just put up on the stream C++ training and we just went to town with this stuff. I didn't have any slides or anything like that, so some of this I may or may not use. We already did this. This one's a bit messy. So our initialization list will define our vector with elements. Okay. So this is the same. We already had this problem. I already did it. Except I think I changed it to handle user input. So here. I don't know if I'm going to bother. Let's leave 10. We already covered 10. And then, perfect. So we'll do a selection sort. I just want to look at what else we got. Excuse me. Actually, I might do this since it's all done. Since we also got functions covered in here. So I'll do that as a... I think I might mix this as a demo and a problem. Hey Mema, sorry guys, I'm a bit off the stream or the chat. Okay, so the sound is fine. Sure that you pushed at the prompt for GitHub username. Oh, yeah. I'll do that off screen. Thanks. It does hide my password, but like sometimes if I hit, anyway. Yeah, it's pushed now. Should be up there now. Oh. Looks good. 3 minutes ago. Awesome. Okay, so so I think from that demo there, sorry. Oh, final question. Mema, do you have YouTube? I just started streaming on YouTube today. I don't know if you guys are streamers or not, but I set up a, here's my email. Hold on a sec. I should probably actually, I'm going to go on my other laptop here and verify myself on Restream, and then I'll explain what I'm doing. I better verify myself because I just started using Restream today. My username is eats@joes. Yeah, bear with me. I'm just on my I'm on my MacBook here. I don't want this Restream to screw up because it's cool. It allows me to perform one single stream, but send it off to Twitch and off to YouTube at the same time. Perfect. So, okay. I don't know if you guys have streamed before, but this is pretty cool. We'll have to look at this. So I just signed up for this, like literally, I start streaming at 10 a.m. Mountain Standard Time. At 10 a.m. Mountain Standard Time, and I was running a bit late, and I thought I want to stream to YouTube and Twitch at the same time, and I use a program called OBS. And I thought it would allow me to do that. OBS would allow me to stream to 2 places at once, but I need this intermediary service, I guess, to stream to, and then they fork my stream to either Twitch or YouTube. So I just started on YouTube as of literally like a minute ago, or like I've been streaming for 2 hours and 29 minutes here on both Twitch and YouTube by the looks of it. And I've only got 3 people on Twitch, I'm dropping, and also very few on YouTube. But it's kind of neat. This Restream allows me to go on YouTube. So anyway, my YouTube is, I couldn't come up with a name. So that's me on YouTube. So yeah, I'm gonna do both. I'm gonna stream to both and see what works. I'm a big fan of Twitch, but I'm having a few issues with Twitch. I'm supposed to be part of the affiliate program, and I got approved for that like last week because I met their criteria, like how many viewers and subscribers and all that stuff. And I signed up for it, and you have to put in your tax information, like because you can actually earn income. So I put in all that, and it's frozen. It's like there's a bug. I'm stuck on step 3, and they said I've been approved, but I can't get to the final step, and nobody seems to want to help me out. So I don't know if I want to stay too embedded with Twitch if I can't really do what I was planning on doing. Anyway, yeah, so I'm on YouTube as well. Okay, so let's see. So we got a demo and a slide to do. So I want to snap that. Wow, that doesn't snap too well. I think this is what. Okay. So let's create a problem. What's the best way to crack a RAR file password? There used to be a company out there that you can buy the software to crack RAR passwords. I can't remember the name of the company. Yeah, I can't remember. Quantum computer plus brute force. Yeah, probably. Yeah, if you think it's a common password, I've got a password list for you. We actually did, M3Chan1K. If we go, since you're asking, if you go up onto my stream's GitHub, earlier this week, we were running Kali Linux to crack the password for my wireless router. And I haven't pushed the password file up yet because I'll show you. I'll show you. Well, actually, I can't show you. I've suspended my virtual machine. But I am about to put up the text files that contain... Yeah, I didn't even push it on here. Just bear with me. I'll tell you what I'm doing in a sec. Here we go. Here's one of the password files. I just haven't had time to push these up. And yeah, I do have LinkedIn. I'll probably share that a little bit later. I'm just trying to kind of figure out what I want to expose about myself and what I don't. So sorry, Tamort. I'm kind of... If you whisper me, then yeah, for sure. I don't mind sharing stuff like friend requests and whispers and stuff, but over the chat, I typically don't. And I mean, you see my email in my GitHub account. You'll figure me out quick enough. Anyway, merch M3Chan 1K. I'll have this password list up. In this password list, I've got 500 million of real passwords that I'm pushing up to the internet. And yeah, it's literally almost 500 million passwords of real passwords. And they were gotten off of Troy Hunt, who is this, he's a Microsoft MVP, and he does a lot of security. And he put up this blog post on the 22nd of February, and I read this on, I read this bad boy on my Flipboard. Thanks for the follow, M3Chan1K. So I read this article on my Flipboard because it knows I like reading this kind of stuff, and I was shocked. I mean, I'm not a hacker, but I have used Kali Linux to crack wireless routers like my own, just to play around. And this dude released a password file that contained 501 million plus owned passwords that came from various locations. I thought I remember reading things like the PlayStation Network passwords, and I don't know where the passwords came from, but they're supposedly real passwords. So he, unfortunately, SHA-1 hashed those passwords inside this password file. So you can read this article and download his 500 million passwords, but they're all hashed. They're one-way hashed, which means you can't crack it unless you've got a powerful rig to crack it, or like SHA-1 hashing algorithms, hashing encryptions. How they work is they don't decrypt to plain text unless you enter in what is encrypted. So it's kind of like if you ever work at a like, let's say, an enterprise web development company, let's say, and in their database they store people's passwords, right? They create user accounts for their system and they store the password. Well, you don't store plain text passwords of your users inside your database, because all of the engineers at the company will have access to that database, all of the QA people, all of the management, pretty much anybody is going to be able to see. Thanks for the follow, Tamort. All of those people are going to be able to see those passwords, and they're going to just float it out there anonymously, and not cool. So what they do is they SHA-1 all of the passwords before they insert them into the database for that user. The only way to decrypt a SHA-1, let's just say SHA-1 is just a random set of hexadecimal values. You know, something like this would be like a SHA. I'm trying to get hexadecimal, but you know, it would be just this big long string that's hashed using the SHA-1 algorithm. Now, to decrypt that to plain text, you decrypt the SHA-1 hash by using the key, which is the actual thing you hashed in the first place. So let's say my password is password 1234. And that's what this hash string is. This is password 1234 hash. Well, the only way to decrypt that and to verify that that password is 1234 is using itself to decrypt it, if that hopefully makes sense. Well, how would you know? Well, let's say you're the user and you're logging into your Facebook account. You put in your username or email, and then in the second field you put in your password. Well, that's great. This goes across as clear text to Facebook. Then they SHA-1 hash or encrypt password 1234. Now it's hashed. All you need to do now is compare that hash against the stored hash in the database. If it's the same, then you know that person has entered in their password successfully. If it's different, they fail. So anyway, this guy has supplied all of those passwords, but they're one-way hash, so you can't decrypt them theoretically. But there's a guy out there who did crack almost all of them. And so what I did is I took his work and if we go back to here, we can look at this Mex 66666 guy. He decrypted all of those SHA-1 passwords. So anyway, I've put them all together in a bunch of files and uploaded them to GitHub, which I'm currently need to finish, obviously. But if you want to crack your RAR password, assuming that the password for that RAR archive is done by probably just some guy who probably used a password that he would commonly use, there's a good chance his password is in that password file. So you may want to you could use brute force, where you would define these filters, or like you'd say, I don't know how to define them specifically, but you might say D for numeric values 10, and then you might say numeric, well, I shouldn't say it. I'm kind of going way off on a tangent. You'd say A through Z, then you'd see capital A through capital Z, then you'd say, you know, use all these as brute force, and then you also might throw in some special characters, and these might be all your brute force, and you might say the password's length could be from 0 to 25 characters using all of these character values. It's pretty tricky to find out. Well, it's almost like, you know, how many characters are there? 26 times 2, so you got 52. Plus 10, you've got 62. Plus, let's say, another 6 or 7. Let's say you're at 70 characters. So 70 to the power of, let's say, up to 25 long. If you want to do the math on that, that's how many brute force attempts you would have to do to crack that password using these special characters. It'd take a long time. Does that equal to more than 500 million? Well, let's plug it in. So let's assume we've got 70 characters to the power of 25 in length. Like, how many of those characters could potentially be used? And my math may be a bit wrong, but, you know, so we basically move that decimal point 46 places to the right, and we would have, you know, trillions of permutations that you would have to brute force. So you would need some kick butt rig, right? You'd need to have a password cracking software that uses OpenCL or CUDA, that uses like C code on the GPU, which is way faster than a CPU. Or you're probably better off downloading 500 million clear text passwords, which would probably take you a few days to run on its own right. That's just a high level idea of how to do it. But what is that? Find password in RAR file. What was the name of that software? Brute force with a mask. So that mask is kind of like where you could say the first 10 characters are going to be alphanumeric. The last characters are just going to be numeric. You can kind of create these masks. But that might not help you unless you have an idea of what the password might be. I don't know. I guess there's different WinRAR password crackers. You could try them. Good luck anyway. Let me know how that goes. I'm curious if you could make that happen. Okay, I'm way off on a tangent. So we're doing a problem. And what was the problem? I even lost my way. So vector, we already did that. So we'll close this. I might actually bug out. I've been streaming for about 3 hours now. And I think I might actually bail and come back. I'll come back in an hour, but I'm going to make some breakfast and have another cup of coffee. But when I come back, I will finish the problem. And the problem's going to be asking the student to create functions to calculate the area of, well, maybe I'll make this as a demo. And then I'll make a problem based on this. So, yeah, you know what? I'm going to bail right now. And I'll come back in an hour. So, sorry, guys. Thanks for the follows, all of you. If you follow me, clearly you'll get an alert saying I'm back online. And I'll be back online in an hour, hour and a half time. Later, a little bit later in the afternoon here. And we'll continue on. So, cheers, guys. I'll see you in a bit. Bye.